So this fourth problem is a problem that's really interesting because it takes stuff that we learned in our linear applications and turns it into a quadratic application. It actually starts in 7th grade and then kind of goes through and shows you how math builds from concept to concept. So when I read this problem, the first thing I notice is that Alice Algebra is a gas station operator. She currently has 1,000 gallons of gas in reserve and is currently selling that gas for $3.19. So we have these two key pieces, right? We have that she has 1,000 gallons of gas and that the cost for the gas is $3.19. But the interesting thing about that is the first question that says, how much is the gas worth now? What's the value of the gas? Well, the value of the gas would be to take the gallons that you have and then multiply that times the value or the price. And then, so this is just a 7th grade math problem, right? It's just going to be 1,000 gallons times price. Now, I do this in the problem, not because we need to worry about 7th grade anymore, but because it will really help you understand how your previous knowledge of math is going to make your current new learning make more sense. So if I sold this right now, we would have $3,190. So the next question is, okay, so Al is receiving gasoline. She owns a store and she's receiving gasoline at a rate of 100 more gallons per day. I mean, per week, forgive me, per week. So what that means is that we just have a problem right here that's just y equals mx plus b, right? What do I mean by that? Well, what happens is if I think about y equals mx plus b, this says per week. So this is the m, and this is the initial value, which is b. We used to call that the y-intercept. A better explanation of what that is the initial value. So that means that y equals mx plus b, but in this problem, it tells us to use g. So we're going to use g of t, and that is equal to 100 gallons. That is our rate. Again, why is it the rate? Because it says I'm getting more of these each week or per week. Each and per are indications normally of a rate of change. The input value is t, not x. Remember, this is our model, but this is our problem for this example. And our initial value is 1,000. Okay. Now, the next part of the question says the price of gas is dropping by 10 cents a week. Okay, so that's the same idea, but now we're talking about the money. So it's dropping by 10 cents per week. That's again my slope, but keep in mind this key part right here. It says dropping, and dropping means negative. So when I write this out, again, it's just going to be y equals mx plus b. That's our model for having a rate and an initial value. The initial value for this one is here. And then my equation, it tells me to use P. So P of T is equal to my rate, which is 10 cents. I can't put down 10 because that would be $10. I need to put 10 cents. And I also need to put a minus on it because it's dropping. My X is really a T. It says right there to do that. And then my initial value was $3.19. So what's really neat now is it says write an equation for the value to calculate the value of Al's gas from your equations from part B and C. What kind of function is this? What they want me to do is take this 7th grade math problem and they want me to update it with those linear equations as a product, because the value is still going to be equal to the gas, but it's now G of T, the equation above this, times the price of the gas, which is P of T. All right, and so when I fill that in, V of T is now going to be equal to 100T plus 1,000. I just got that from right above, right? G of T we did here, times P of T, which is negative 0.10T plus $3.19. And that is a quadratic. It doesn't look like one now, but once we multiply it together, it is a quadratic because it has 2 t's, and t times t is t squared. Now, that equation will be really helpful if I ask you something like, when would the value of the gasoline be 0? Because you could easily set this equal to 0. You would subtract and divide and find out that she has 31.9 weeks before she goes broke. However, a more useful equation would be to put this in standard form, which we're going to do in just a second. Here we go. So I'm writing that across the box. I'm just going to use the box method, which we use quite often. You could FOIL it, but you'll see why the box method is just a really good thing to have in your math toolbox pretty much forever. So when I box this up, negative 0.1 times 100 is negative 10 and is t squared. There's the quadratic. Negative 0.1 times 1,000 is negative 100. 100 times $3.19 would be 319, but there's t there. And then 1,000 times 3.19 is 3,190. Notice that this is the initial value I had here. The initial value will remain the same in the 7th grade problem as it will here. So when I combine my like terms, just like we've done before right there, our v of t is going to come out to negative 10t squared plus 219t, and then plus 3,190. Again, the y-intercept, if I plug in 0, is still that, right? If I put 0 in for the amount of time, the amount of weeks, then I go back to the original problem as I sold it as soon as the problem started. So now this value can now be used to find the maximum amount. And I threw in another thing to show you how Desmos does things to predict the worth of gas at several weeks. The best way to organize a problem like this is to actually make a chart where you have t, the input value of 4, 8, 12, 16, and 20. And then you have the output value v of t, and you just organize this in a chart. It's just a whole lot easier way to organize the information rather than saying like, you know, blah, this is that, that's that. So when we go into Desmos, again, if you already have Desmos in here and you need to clear it out, just click on the URL and just say reload. It clears it out really nicely. So the way we do that is we put in the equation, which we found right here. So this is the model we'll be using for the rest of the problem. And I put that equation in, which is v of t is equal to, and you can actually use the t if you're not going to graph. This doesn't really matter. So again, we don't really care about the graph here. Make sure you don't make any typos. Desmos is very flexible with letters as long as you know what you're doing with them. Just make sure you didn't make any typos, and then you can literally just come over here now and watch this really neat thing you can do. You can say, hey, Desmos, what is v of 4? Okay, hit enter. What is v of 8? Cool. What is v of 12? What is v of 16? Just don't make any typos. And then what is v of 20? And you can check to see if you made any typos, and those are the answers. Okay, and I have a nice little screenshot of that right here so that we can write it in there. Now, the interesting thing about that is some of you might be using like TI or Casio. They have the same feature. It's just called table. So if you look at your TI calculator where you hit graph, right above that is a table. And if you hit second graph, you will go into the table. And for a Casio user, you would go into the menu and there's a table in there. So there you go. And so now you can see this nice little table, which spit out in Desmos, but it also can spit out in a calculator. So using the same equation, how would I find the maximum amount? And if you've watched the other two videos, finding the maximum amount is an important thing to do, but it's not H and K you may have learned previously. This is going to be minus B over 2A, F of minus B over 2A, which simply, again, means your input is to do this and your output is to plug this into the function. I always like students to know what is happening before they start. So what is our input? Our input is T, right? But our input is T in weeks. That's important to be able to answer the actual question. The question says, when should they sell this? So if I get an answer, I don't want to say days, it's weeks. And the output is V, or value, which is going to be measured in dollars. And that will answer the second part of how much money is this. So when we come back up here, you know, this is A, this is B, this is C. Now we're just going to come down here and say, okay, well, that means I would have negative 219 divided by 2 times negative 10. And then I'm going to plug that money in, and I'm going to figure out what that will produce. So let's go back to Desmos, and I'll show you a really quick way to do that because you already put the function in. So to do this on Desmos, you're just going to do negative 219 divided by 2 times negative 10. And so this will happen at 10.2 10.95 weeks is when she's going to get her maximum amount of money. But as an operator, like, how much is that? Well, the cool thing is we already have a function in here. So we could just say, hey, what is B of 10.95? Because we already had the function. And that comes out to $4,389. Now, be careful when you round this. There is no such thing as a 0.25 cents. So it's $4,389.03 is how much money she will make if she sells it at that time. All right. So make sure you round money to 2 decimal places. All right. And you can see that I have a nice little screenshot of that right here. So the next thing, the last part of this problem is, well, what happens if she needs $4,000? I mean, yeah, it's great that she can sell this, but let's say she's getting a delivery of coffee. She runs a gas station. So maybe there's some coffee that's going to be delivered. And if that coffee comes in, she has to have $4,000. The question is, she doesn't just want to get $3,190 for gasoline. She sees that the price is dropping, but if she needs $4,000 to pay the coffee person, how do I do that? Well, that again is, this is the output, right? This is find this output value specifically. So that means we set the equation equal to 4,000. And the equation we had was negative 0.10 t squared plus 219t plus 3,190. Okay, and then I'm just going to solve that with the quadratic formula. Again, I got that equation from right here. And so I'm going to solve that equation using the quadratic formula, which I can still do with all this stuff in there. I can clear it out if I want to, but I can just start typing here, right? So I can just start typing. Ooh, one problem, I can't start typing yet because when you do the quadratic equation, it has to equal 0. So you have to subtract 4,000, okay, before you start typing stuff in. And that will give us 0. Not that the problem's asking me when will she be bankrupt, but it asked me when it was 4,000. But the problem is the quadratic formula requires you to set the problem equal to 0. And so you have to take a second and do that. That'll give me negative 810. So my A, B, and C, my A, B, and C are here. Keep in mind that this equation and this equation are the same. One is just modeled for the quadratic formula. So one more time, how to do that. A is equal to negative 0.10, and then B is equal to 219, and then C is equal to negative 810, and then the quadratic formula is negative B plus the square root is found under here, B squared minus 4AC. By the way, on SAT, you would have to know that. If you're taking a Virginia State SOL, it is provided, but on an SAT, you have to know it. Highlight the whole thing and divide by 2A, and you get the first one is at 3.705 weeks. To get the other one, because there are 2, you have to copy it. So I went like that, and I copied it, and I pasted it, and I changed it, and we get our other answer. Okay, so you can see those answers right here. Negative 4.7 and 17.187. I'm not sure. Oh, I see what I did. Please make sure you don't make a little boo-boo. I copied that down wrong. My brain caught that. It's supposed to be negative 10, not negative 0.1, which was earlier in the problem. My brain just held on to that. Now that's good that you see that mistake. So now that you have the right thing, you see the right answer. And if you were using Desmos, watch how easy it is to change that. Like, these answers don't make sense. 2,000 weeks. That's because that's supposed to be 10. You just change it, bam, blammo, it prints out the right answers. So the gas could be sold for $4,000 either at week 4.173 or at week 17. So each has 2 choices. But if she sells it here, she can't sell it again, because if she sells it at 4.7, she's out of money. Now, we could also solve this in Desmos by graphing it. So just to review that, we talked so much about the quadratic formula. What if I wanted to graph this? Okay, I'm just going to get rid of everything in here instead. Now, the way I would do that is I could literally leave this here, right? And then I could say, I want to know when this equals 4,000, okay? Then I'm going to go into my graph, okay? I don't see it, okay? Sometimes, again, you're not going to see an equation with a t in there, but let's see if it works. We mainly need to change the graph setting, the wrench, so that it will actually show up with 4,000 on it, right? So I go into here and I change the range of the graph from 0 to 4,000. Let's see if we see anything. So I see stuff. I see the parabola in red, and this one is in purple. And if I scroll out, I'm good to go. So as long as you're using function notation, Desmos can figure it out. And so you can see that 4.173 that you see here, and you can see here the 17.187. So you could still solve it by graphing. You could also even find the maximum right there. Look at that. So that's even the maximum that was asked about earlier in the problem. Here, I'll scroll up and show you. That maximum is right here. So you can actually do a lot on Desmos. It's good to know how to do the algebra and use Desmos. So quick review. This problem started out as a basic, multiplication problem. We then found two linear equations by using y equals mx plus b, m being the rate, b being the initial value. There were two different things, so we had two different initial values, two different rates. But then when I multiply them together, I got a quadratic. And that quadratic can be analyzed with the vertex formula or the quadratic formula, depending on what's being asked. If it asks for a maximum, use the vertex. If it asks for a particular value, for a particular output, you would use the quadratic formula or just graph it all. All right, I hope that was helpful. If there are parts you need to watch again, please do. Very good learning going on in this problem, though I know the first time you see word problems, it can be a little bit overwhelming. Thanks for watching.